this and the higher derivatives. Now let us focus our attention into derivatives of trigonometric functions. So we know that basically there are 6 trigonometric ratios: sine, cosine, tan, cot, cosecant and secant. So the derivative of sine x will give you cosine x. Derivative of cosine x will give you minus sine x. Derivative of tan x will give you secant squared x. Derivative of cot x will give you minus cosecant squared x. Derivative of cosecant x will give you minus cosecant x cot x. And derivative of secant x will give you secant x times tan x. So these are the important trigonometric functions derivatives. So how we remember this thing? There is an easy technique to remember the formula. As you see here, there are 6 trigonometric ratios, out of which 3 trigonometric ratios start from the letter C: cosine, cot and cosecant. So if you see the derivative, you have a minus sign here. You have a minus sign here, as well as you have a minus sign here. So what I want to say to you, the derivative of a trigonometric function begin with the letter C, then in the derivative there is a minus sign. So derivative of cosine minus sin x, derivative of cot minus cosecant squared x, derivative of cosecant x minus cosecant cot x. Remaining 3, there is no need to put minus sign. So like that you can remember the formula. And also remember, in lower classes we have learned sine squared x plus cosine squared x is equal to 1. Let us see one simple example. Find the derivative of y equal to minus 10x plus 3 cosine x. It is very simple. The derivative of minus 10x will give you minus 10, and this 3 you are keeping as it is. Derivative of cosine. What is derivative of cosine? A while ago I told you, any trigonometric ratio starts from C, we have to put a minus. So derivative of cosine x will be minus sin x. Find the derivative of y equal to secant x times cosecant x. So here we need to apply product rule because I have two functions. Secant x is my first function, cosecant x is my second function. By applying the product rule, we know that the product rule tells you u dv plus v du. Okay, so what is u? Secant x. What is v? Cosecant x. So derivative of cosecant x, it starts from the letter C. So I will get minus cosecant x cot x plus, we write v term, then derivative of u. What is my u? My u is secant x. So derivative of secant x will give you secant x times tan x. Another question, find the derivative of y is equal to 1 plus cosecant x upon 1 minus cosecant x. So it is easy to know that we have to apply quotient rule for this problem because we have a function up and we have a function in the down. So what is quotient rule? V du minus u dv, this all divided by v power 2. So here I am writing v, then this is du, derivative of the function u. What is my function u? My function u is 1 plus cosecant x. So derivative of 1 will be 0 and derivative of cosecant x will give you minus cosecant x cot x. Then as per formula we write minus, write u term, so this is my u, and then derivative of v. So what is my v? My v is 1 minus cosecant x, this one. So derivative of 1 will be 0 and derivative of minus cosecant x will give you minus cosecant x cot x. So here we have a minus. In the formula there is a minus. So minus times minus will give you plus. Divide by 1 minus cosecant x the whole square. Because in the denominator we need to write v power 2. No need to differentiate the denominator. We have to differentiate only in the numerator. Okay. By simplifying this, I will get 1 times of this term will give you this. Minus and minus will give you plus cosecant squared x cot x. And here we'll have minus 1 times cosecant x cot x. I will get minus cosecant x cot x. And finally, cosecant x times cosecant x cot x will give you minus cosecant squared x cot x. So here this term and this term gets cancelled. We have left with first term and the third term. By adding this will give you minus 2 cosecant x cot x over 1 minus cosecant x power 2. The next one, derivatives of inverse trigonometric functions. Like trigonometric functions, here also there are 6 formulas. So the derivative of sine inverse of x will give you this. Derivative of cosine inverse of x will give you this. And this is tan inverse of x, cot inverse of x, secant inverse of x, cosecant inverse of x. So you need to remember these formulas. As I told you, again, you can simply remember wherever the function start from the letter C, there is a minus in the column, in the formula. If I have cot inverse of x, then we have minus 1 in the numerator. If I have cosecant, then I have minus 1 in the numerator. So out of 6 formulas, 3 formulas will have minus sign. The remaining 3 formulas, they don't have minus sign. Find the derivative of y equal to x power 2 cosine inverse of x. Again, here we will have two functions with the product. So we have to apply product rule. So u dv plus v du. So this is my u and this is derivative of my function v. So a while ago we studied the derivative of cosine inverse of x equal to this one, minus 1 over 1 minus x squared, square root of 1 minus x squared, plus v du. So du means derivative of u. What is derivative of u? The derivative of x power 2 is equal to 2x. Same way, we can solve x into tan inverse of x. So again, treat x as u, tan inverse x v, apply product rule, we will get this one. Here we have to apply quotient rule, u upon v. So v du minus u dv divided by v power 2. We can extend the derivative concept into exponential and logarithmic functions. So again, we need to remember 3 things. The derivative of e power x will be the same, e power x. The derivative of ln x will give you 1 over x. The derivative of a power x will give you a power x times ln a. Find the derivative of y equal to a power x sin x. Okay, so see this one. This is like u and sin x is my v. So once again we apply product rule. So we have to keep u, then derivative of sin x will give you cosine x, plus we have to keep sin x, derivative of a power x will give you a power x ln a, this formula. Now second question, y is equal to x to the power 2 ln x. So once again we apply the product rule uv. So u dv plus v du will give you this one. We can extend this derivative concept and we will get the equation of the tangent line to the curve at the point x1 comma y1. The formula to calculate equation of the tangent line to the curve is y minus y1 is equal to m multiplied x minus x1, where this m is nothing but slope of the function. That slope is nothing but derivative of variable y, dy by dx. Let us see this example. find the equation of the tangent line to the graph of the function f of x equal to 4 minus x power 2 at the point minus 1 comma 3. So first we find the derivative. So the derivative of the function will give you minus 2x. Then I need to calculate the derivative at the point minus 1 comma 3. That means I need to substitute x equal to minus 1 in the derivative. That will give you 2. Then write the formula. Then replace y1 equal to 3, m equal to 2, x1 equal to minus 1. We will get this one. Then by simplifying this, I will get y minus 3 equal to 2x plus 2. Finally, we end up with y equal to 2x plus 5. This is also the same idea. First, find the derivative. Will give you 1 by square root of x. Then substitute the point in the derivative. Will give you 1. Then write the formula. Replace x1 value. Replace y1 value. Replace the slope value. By simplifying this, we will get y equal to x plus 1. The same formula we can extend to calculate the equation of the tangent line to the curve at the point x equal to a. So this is the formula. Y is equal to slope multiplied by x minus a plus f of a. So see this example. Here my point is x equal to 0. So first step I calculate f of 0. F of 0 means in the function we replace x by 0. That will give you 1. Then second step, find the derivative. The derivative of 3x power 2 will give you 6x. The derivative of 4x will give you 4. And then in the derivative, substitute x equal to 0. So my derivative, if I substitute x equal to 0, will give us 4. Then write the formula. And finally, by simplifying this, we will get y equal to 4x plus 1. So these are the problems for you to do as an exercise. We have given answers also in the side. Do the problems and check the answers.